Hello everyone. So I was thinking about making a video on the GATE chemical engineering syllabus and the marks distribution for quite a long time, and finally I came up with this video. I hope it helps you. So the GATE chemical engineering examination is a typical 3-hour examination, objective multiple choice question type, and it is basically divided into 3 sections: general aptitude, engineering mathematics, and chemical engineering. So roughly there are 15 marks on general aptitude, 15 marks on engineering mathematics, and 70 marks on the core chemical engineering questions. So a total of 65 questions are there. Some of the questions are like 2-mark questions and some of them are 1-mark question. To be exact, 35 of them are 2 marks and 30 are of 1 marks question. And number of students who have appeared year-wise are like in 2012 around 11,000 students, and the numbers have been increasing. We are having around 16,000 students appearing for this examination every year. Now if you look at the topics which needs to be covered within the chemical engineering, you'll find that of course aptitude and mathematics consists of around 27 marks. This is a typical marks distribution in 2018, followed by calculations, thermodynamics, fluid mechanics 15 marks, heat transfer 10, mass transfer 8, CRE or the chemical reaction engineering 11, and these are of lower contribution, which is process control, instrumentation, plant design and economics, and chemical technology. In 2017 also we had a fairly that type of system, and mass transfer was the highest contributor. In 2016 we had engineering mathematics aptitude at their usual level, followed by thermodynamics, CRE, and a lot of questions on plant design and economics were asked. In 2015 aptitude mathematics remains the same, while thermodynamics and mass transfer are the maximum contributors. Plant design economics was at 5 marks, heat transfer and fluid mechanics are also on 9 marks each. 2014 also fairly similar type of distribution, and one thing that you can find here is that in all these years the questions on thermodynamics have been the maximum. In 14 it was like 13 marks, 15 also 13, 16 13, 17 10, 18 also 13. Then mass transfer has been also a major contributor over the years. Now looking into the inner details, the engineering mathematics consists of linear algebra, the calculus, differential equations, complex variables, probability and statistics, and numerical methods. If you just go through each of them, you will get to know that what are the topics which are required exactly. There are no questions which comes beyond these topics. The contributions have been fairly consistent. Coming to process calculation and thermodynamics, the major book that people refer to is Himmelblau. Some of them also practice from Ram Prasad, and the numbers, the questions have been fairly consistent. You can see there are 13 marks specifically from this section, and it is one of the most mathematics intensive sort of a subject, where a lot of calculations, a lot of details about Raoult's law, vapor pressure, fugacity, Margulies model, and everything needs to be covered. So the syllabus is definitely very extensive. For thermodynamics people prefer Van Ness and Smith, and some go for other books also which they find to be comfortable with. Then we have got fluid mechanics. It is also a major contributor in all the years, and the fluid mechanics is basically people use either McCabe or they go for Sengel to study about the fluid mechanics. The questions have been fairly easy, considering that this syllabus is very tough. Fluid mechanics in itself is a very extensive subject, but the questions comparatively are slightly easier, and I would say that you should start by preparing last 10 years. If you have prepared the last 10 years, you get a fair idea of what you need to study, because if you go by the book, a lot of details are given in the book. Coming to heat transfer, it's a very simple, very condensed syllabus, wherein conduction, convection, radiation, Then heat transfer coefficients are the major topics, and apart from that you have got to have the basic understanding of double pipe shell and tube heat exchangers, evaporators, the process calculations, and of course the boiling, condensation and evaporation. The questions are also fairly constrained, and you can refer to DQ, Kern or Hallman for this particular subject. In mass transfer also, this is one of the major contributors, as you can see, although in 2018 the contribution was slightly low, but if you look at 17 and 15, they were quite very high. The syllabus seems to be small, but this subject is very big. There are a lot of unit operations that needs to be studied, like distillation, absorption, leaching, liquid extraction, drying, humidification, dehumidification and adsorption. Apart from that, you need to study a lot of laws like Fick's law, molecular diffusion, mass transfer coefficients, film penetration, surface renewable theories. A lot of questions I have seen over the years on this theoretical aspect of surface renewable theories. People refer generally B.K. Datta for this subject. It's fairly very includes extensive extensive book wherein you find a lot of details. Then if you look at the CRE, of course it's a straightforward syllabus, and the questions have been very consistent sort of. There are 10 marks or 11 marks coming every year, and the people prefer Levenspiel for studying CRE, chemical reaction engineering, or you can also refer to Ram Prasad. Ram Prasad is actually a must for studying all of the subjects in one book, although for details and getting the top ranks you need to go into details in Levenspiel or some other book which you find, like Fogler, some study Fogler, whoever wants to go into better marks in all of them. Then comes instrumentation and process control. Now this is a subject which is very important. People study a lot in this. There are a lot of scope for new researches or new instruments, and its contribution in chemical is also fairly consistent, and people generally refer to books like Stephanopoulos to study the details, and that is more than sufficient. You don't need to go into another more books as such. Then you have got plant design and economics. What we have seen that this is a slightly lower contribution, but one of the years in 2016 its contribution was very high, 10 marks, so you should not ignore it completely. In IRR, MIRR, concepts of internal rate of return, markup internal rate of return, how to calculate the economics of any project, how do you perform the 6/10 rule, like expanding in the capacity. If one vessel costs you 1 lakh rupees and has a capacity of 1 meter cube, if you go for 2 meter cube, what will its cost be by approximation methods? So this is one of the important subjects from GATE point of view, and also in your future life many such situations will come where you need to evaluate technical, commercial feasibility, and at that time these concepts do help. And last but not the least, the chemical technology. Its contribution has decreased over the year. You can see a decreasing trend from 2014 onwards. Currently very low questions are asked from this, but you can go through some static portions or maybe previous year to get an idea that the questions are mostly repetitive over the years, and it is restricted to these topics only. So from my side, I'll wish you all the best, and put in your efforts and give it your best shot. You will definitely achieve success. Thank you.